In this lesson, we are going to learn about field energy density. Field energy density, small u, is defined as potential energy per unit volume. We have seen that the energy stored in a capacitor is given by half CV square, where V is voltage, this is volume. So let's write clearly, this is volume. And volume of a parallel plate capacitor will be given by A into D. Okay, the space between the plates. So this is A into D. We know that the capacitance of a parallel plate capacitor is epsilon naught A by D. And here we have got A into D, this one. V square. The potential difference is E into D because E is uniform here, E into D. So we'll get E square D square. So now this A cancels, this D square cancels, and this gives us the formula half epsilon naught E square. Even though we have derived this for a parallel plate capacitor, this formula is applicable anywhere where electric field is present. In any region where electric field is present, there is an energy per unit volume that we call field energy density, and that is given by half epsilon naught E square. Now suppose we have got two parallel plate capacitors. The plates are of same area and they have got the same charge, plus Q and minus Q. The only difference is the distance between the plates here is D and the distance between the plates here is 2D. So question is, in which of the capacitors electric field is stronger between the plates, and in which of the capacitors more energy is stored? Now if you look at electric field is given by sigma by epsilon naught, and sigma is charge per unit area. So here charge is same, area is same, epsilon naught anyway is a constant, therefore E1 will be equal to E2. What about the potential energy? Electric field is same, right, in both these capacitors. In this capacitor, the electric field is in double the volume. The volume of the capacitor is double the volume of this capacitor. So the electric field is present in double the volume, and the electric field is of the same strength. The energy stored per unit volume is same in both the capacitors because electric field is same. And since the volume of this is double, the energy stored in this capacitor will be double. Therefore, U2 will be twice U1. So in this capacitor, the energy stored is half the energy stored in this capacitor. In these two capacitors, the electric field is same, E1 equal to E2, E1 equal to E2. But since the volume of this capacitor is double, the potential energy stored is double.